Hello, sir. I'm Deepak Adhikari. I'm here to demonstrating the virtual experiment of D flip-flop using the NAND gate. Uh, Here I'm going to verify the truth table of D flip-flop using the NAND gate, where D flip-flop is also called the delay flip-flop, and here the D stand for data, input data, and it is very useful in main technology which have very small in structure and which performance is very high, consuming low power devices, like VLSI technology is used as the VLSI technology. That means for very large scale integration, that means like the IC chip and etc., where small where the size of the devices are very device means apparatus, or where the devices are very small. Because of these types of latches, here flip-flop or latches refer to the electronic device that sends its output immediately on the basis of the applied input, where here applied input are 0 and 1, where 0 refers to the low and 1 refers to the high. 0 refers to the no power supply, or 1 refers to the power supply at a specific time. And others inputs are the set and reset, and it also has a two output, that is Q and Q dash, where Q and Q dash are complementary to each other. That means the Q is the output and Q dash is the complementary output. Here I use the laptop and mobile as a apparatus for this experiment. And flip-flop, the description of the flip-flop is it is an electronic circuit with two stable states that can be used to store the binary data. The stored data can be changed by applying the varying input, that 0 and 1. Flip-flop and latches are fundamental building block of digital electronic systems that are mainly used in computer electronics nowadays, electronic devices and computer that we use in nowadays. Literature review, the flip-flop is a fundamental building block of digital circuit that is used to store the binary information. It is essential a two-state device that can be in one of two states, which can be represented by the logic level of 0 and 1. Flip-flop are widely used in digital electronics, including computer memory. I already told that. These are the history of the this flip-flop or digital circuit, where SR flip-flop is invented by C.E. Shannon in 1938, and where this D flip-flop is the what we say, it's another types of SR flip-flop, modified version of SR flip-flop, where D single data input is connected, where D single data input is connected directly to the S, and NOT gate is connected with R. As shown in the figure here, SR flip-flop, we see that the output SR flip-flop in unpredictable state, so we apply single data D input as input in the SR flip-flop to get a stable data or a stable input. In this types of flip-flop, SR flip-flop by connecting the R input through the inverter and S input directly to the data D here like this. And I use this methodology to do this experiment on this virtual lab, and I got these observations. Let me show how I did this experiment. This is the virtual lab where I did experiment, virtual lab. Here I am performing the logic gate of D flip-flop on this kit. Where this is the truth table where I take the data. At first I apply power, so the output is 0 and the complementary is 1. I add the data here. There is no change in the marks because there is no output here. When I apply data here, then there is also no change here. And I added the data here. When I apply data with no clock, then the output is 0. Let's try by applying clock only. What happens? See, there is no change in the output. That means it's get reset. Again, let's apply data and apply clock. What will happen? Let's see. That means the output is available here. So this is how I perform this experiment. And when this is the clock diagram that we perform the experiment here, I've shown here. And in this way I have done this experiment. Thank you.